All right, let's look at a few gate problems here. Let's say we have a gate like this, individual down here looking up at it. We're going to do these problems a couple times so you see the ways of getting these. Gate looks like this: 5 foot, 12 foot, 8 foot. Here, let's make it 8 foot here. Let's say usually let's say it's 30 degrees, and say it's water. This individual sees this gate. Here's the axis. Alright, so here's the origin, and here's my y coordinate. We'll identify the centroid, center of pressure. This is y bar, y center of pressure. Well, you have to remember F is equal to gamma h bar A, and then my delta is equal to I bar y bar area. Excuse me. So with that in mind, I recognize that I need to find some simple values here. Gamma A, I'm trying to list them in maybe the least to most complicated. Okay, 62.4. 5 by 12 is 60. So it's 12 foot and 5 foot here. So if you want to, I would suggest working this problem at the same time that I am to see if you get the same answers. Base times height to the third, or 5 times 12 to the third. Now, you may have a particular difficulty here, but look at it like this, okay? I'm actually looking to find the second moment of area here about this blue line. So if, and I'll erase these in a minute, but if I'm actually looking to do that, then I'm looking to move it a distance, whoops, went a little too far, down here, which means that I'm actually looking to find the axis, the I bar about this axis. These, you can't find one here and then expect that to be similar to this. When the parallel axis theorem, you're moving lines parallel to each other. So I've moved the line down here, and I'm going to have to move it back, but you don't have to because we did that already in the derivation. So with that in mind, so you can get rid of all these now. I'm looking at it across here. So actually, what I mean by that is when you're looking to find it about here, the I bar, that is, this is your base and this is your height. Now, if we were looking to find it this way, it would be the reverse, but that's not what we're doing. Since this line goes this way, so too does this one. We could write XX here, and that is equivalent to this. That's why the base is that number and the height is that number. Okay. So here comes our sticking point. You have a triangle which is 30. So I'm going to use my highlighter pen here. Here is one triangle. Let's work off of it first. If this is 30, I mean this angle is 30, I can erase this, but I'm going to just put a variable here, say R or R tilde or something. I don't know. Or here, maybe just make it question mark. So if I'm looking for that, then 8 over my question mark becomes nothing more than sine of 30, which that's nothing more than a half, which means that you move the 2 over here, move the question mark over here, then I contend that question mark becomes 16. So takes care of that. I have another distance down here of 6. That puts me right at the centroid. Another distance down here of 6. Whoop, sorry. So what I need is I need 2 other heights. For this particular case, I need essentially h bar here. However, let's look at my blue triangle now. And in my blue triangle, here's my little question mark. So that distance, here, maybe I could draw it away from there a little bit. By the way, whatever that is, this is too, because this is the same distance, 6 here. What I mean by that is, although visually it doesn't look like it, this blue triangle is the same size as that one, because this is 6 and that's 6. May not look like it, but it is. But that's only because I'm a bad drawer. So I'm going after the question mark here. So it's the same thing. The question mark over 6 is equal to sine of 30 here. And that's equal to a half. So you move your 6 underneath here and you get a question mark of 3. So this distance is 3 and this distance is 3. So I get rid of that because it's in the middle of the drawing. Now I have a good idea of how I can move myself around here to find my h bar and my y bar. H bar is easy, 8 plus 3. Now y bar, it's a little easy too, 16 and 6. Now, we should check something. Here's a way to check it. They have to fit in this pattern of the purple circle that purple triangle that I just drew. So does h bar, wait, here, change ink. Does h bar over y bar equal to sine of 30, which is a half? If I put h bar in there, it's 11 and it's 22, so yeah, I'm pretty much okay from this equation. So I think I have all my information at this point. Okay, so let's take off, go see what we can do here. The total gamma h bar area 62.4 pounds per cubic foot. H bar 11 feet. Area 60 feet squared. Ending up with $4,184. Now, where did it get placed? Yeah, that's good enough. Here's my gate. There's a X hinge load. There's a Y hinge load. There's my equivalent load, 41184. There's my reaction that I'm actually looking for. This is 6 to right here, and this is delta right there. Well, delta is equal to H bar Y bar area. I mean I bar. Oh, I never found that. So this number, 12 to the third, I get 720. So I get 720 here, Y bar of 22, and A of 60. By the way, this is in pounds. So I end up with, hang on, .5454, on and on. So at this point, I could say, we have to remember this is 12. So I'm summing moments about the hinge. I get 12 times R is equal to 41,184 times 6.54, 54, 54, on and on. .184. I get approximately, well, 22,464 pounds. Now, you have the ammunition to actually solve this another way. So let's look at this another way. And instead of actually trying to redraw it, I'm going to copy it. Actually, I don't even need to do that. Here, we'll go to the very bottom and we'll redraw it here. Here's my gate. I have a preloaded pressure here that goes all the way across. And then I have a triangular load because this end here is deeper than that end. How much? It's 8 foot to this end. It's 8 plus 6 to that end. So it's 8 times 62.4, and this distance is 6 times 62.4. Or 374.4 pounds per feet squared. This is 499.2 pounds per feet squared. We have to remember that the gate itself is 5 foot into the page. Here's your 5 foot right there. So the actual load on this, if we want to redo it, There's an actual center load, which is 6 foot down. And there's another load, which is 2/3 of the distance, but it's 12, so it's 2/3 times 12, and that's this distance. Now, what is this load? This is 499.2 from here, but it's over the entire area, or a actual 5 by 12. That amounts to I think I miscalculated it. That amounts to 29,952 pounds. This one is your 374.2, but it's a triangular. So yeah, it's multiplied the same area, but since half of it's missing, you get this. Okay, so you get 11,226. Now don't forget your reaction load, and then don't forget your hinge foot loads, but we're summing the moments about the hinge here, so if we sum the moments about the hinge, we end up with reaction times 12 is nothing more than 6 foot times 29,952 plus this number right here ends up to being equal to 8. So it's 8 foot times 11,226. Now before we go on any further, let's check a couple things. Now I can solve this. Well, let me go ahead and solve it out first, and then I'll come back and show you some checks that can be done along the way that I did not do. 8 times 11226 plus 6 times 29952. Divide that by 12, and you get 22,460 pounds. So if you compare this number with that number, you're off by that 4 digit, which hopefully that's not going to bother you too much. Let me show you a check that you should have, or I should have made along the way. I got a force here and a force here. Essentially, the 29,952 plus the 11,226, 29,952 plus 11,226 is equivalent to 41,178. I'm looking for it. Okay, so this force, the total force, should be very similar, if not exactly the same as that. And you can see I'm off by actually 6 pounds. But that's close enough. And if you want to go back through it and find out, you can carry all these digits if you wanted to. I don't think I did, but if you want to, you would probably find them to be very much similar. So let's complicate this problem now. There is nothing more than this is essentially what I would require you to do on this next week's setup, the next week's in-class exam. So I could draw another one, change the angle, do things like that, but that's not going to get you anywhere. You're not going to learn any more than you would off of this. But I can use this problem to introduce another concept. Or I think what I'll do is I'll just wait till next week. I'm just going to post this video and we're just going to go with it. Next week I'll cover buoyancy and some other things and add some complexities to these type problems.